Alright, in this video, we're going to talk about exponential functions, specifically the parent function, see what that looks like, and from there, in future videos, we can learn how to shift it and reflect it and stretch it and all the different things to move it around. But if you'll notice, we have our f of x equals 2 to the x, and this x being in the exponent, that's what makes it an exponential function. So to figure out what this thing looks like, we're going to use a table of values. We're going to plug those in, and I've just kind of selectively chosen a few x values. We've got a few negatives, we have 0 in there, and then we have a few positives. So now I can plug those points in, see what my y values are, then plot those and get a good idea of what that graph looks like, right? So let's start with the 0, right? So if I say 2 to the 0, I have 2 to the 1, well, that's going to be 2, 2 to the 2, that's going to be 4, so I can fill those points in here, all right? And if we go to the negative ones, we have 2 to the negative 1, which is the same thing. If you remember your exponent laws, is 1 over 2 to the 1, which equals 1/2. And then the same thing is going to happen here. So I'm going to have 1 to the 4th because 2 squared is 4. And then I have 1 to the 4th. So now I have 1 to the 4th and 1/2 here. Okay, so now let's go plot these points. I have 2, 1, 2, 3, 4. I have 1, 2. I have 0, 1. I have negative 1.5, and then I have 1, or excuse me, and then I have 2 and 1/4. So you can see I don't necessarily have a straight line here. What I have is a curved line that is going to continue to grow as I go right to left. Now, if I always plug in smaller and smaller negative numbers like -10, -100, you can see that my y value will continue to get smaller and smaller, thus approaching 0. So we will never actually, in this parent function, cross the x-axis here, which is going to be our asymptote. All right, and if I keep using larger and larger numbers, if I continue on down this way, you can see I'm going to continue that graph, and it's just going to continue to get larger infinitely. So if we talk about what the domain of this thing is going to be, my domain would be all real numbers, because x could be infinite to the negative infinity, and it could go infinitely towards positive infinity, all right? And then my range is going to be a little bit different. If you'll notice, I'm never going to go below the x-axis, which means my range, my y values, have to be larger than 0, okay? So again, this is our parent function for this f of x equals 2x. All right, now let's change it up a little bit. We're going to do the same thing, but we're going to look at it a little differently. So now I have a new function here. I have 1/2 to the x power. Again, I have an exponential function because my x is in the exponent. And so let's plug that in. So I have 1 over 2 to the negative 2. All right, if you remember our exponent laws, that's 1 to the negative 2 over 2 to the negative 2, because I have to apply that exponent to both of them. Now, if you'll remember, that negative just flips my fraction here, and what you end up getting is just 4 over 1. So now my negative 2 equals 4, and in a very similar way, my 1 is negative 1 is going to be 2. Anything to the 0 power is a 1, and now I have 1/2 to the 1 power, which is 1/2. I have 1/2 to the second power, which is going to be 1 over 4. So you can see a little bit of a different action going on here. Negative 2, 1, 2, 3, 4. And then same thing in 1, 2, I have 1, 0, and now I have the same curve, but now it's going down, it's decreasing from left to right. Same thing, my domain is still going to be all real numbers because I can go right and left infinitely, and then my range will still be y is greater than 0, but now I have a different look, right? So in the first one up here, I'm increasing, okay, I have growth. Here I'm decreasing or have decay. And the difference between the two functions is the 2 and the 1/2. So one other special note we want to write for parent functions, and here is the main function. We have f of x equals b to the x. Okay, so that b value could be any number, right? But we know when b is larger than 1, in the case of the 2 up here, we're going to have growth, right? It's going up, left to right. But when b is between 0 and 1, we have decay, as in our case down here with the 1/2, okay? Now then, Some of you may be thinking, well, what if b is negative? We're going to tackle that in the next video, but for now, the main takeaway from this one is to know the basic parent function, and that is f of x equals b of x, where b could be any number, but when b is larger than 1, we have growth, and when b is between 0 and 1, we have decay. All right, hope this video helps, and I'll see you